not all AI is built the same. Pearson AI is built for learning. When it comes to higher education, learning isn't just about finding the answer. It's about building knowledge, understanding, and loving the journey along the way. That's where Pearson's AI comes in. It's trusted. With reliable Pearson content at its core, it ensures accuracy, protects privacy, and keeps learning on track. It's tailored, purpose-built for education. It adapts to the student's level, aligns to curriculum, and is personalized to every learner. And it's built into the Pearson tools students and educators already trust. The result? Students using Pearson AI are 23 times more likely to become active readers. 1 in 3 interactions showed students applying, analyzing, and evaluating. And 1 in 5 went beyond memorization, showing skills essential for deeper learning. Pearson's AI doesn't just support students. It helps educators to do what they do best. Our instructor-led design supports teaching, not replaces it, by reducing admin, scaling personalized support, and keeping educators in control. Available now to millions of learners and educators worldwide. This isn't an add-on, it's part of the learning experience. Because not all AI is built the same. Pearson AI is built for learning.
Hi, everyone, and welcome back. It's so great to see so many of you here again today. I want to welcome you to Day 3 of Shape the Future, our Global Educator Series. My name is Dr. Vince Liardi. I'm our Global Marketing Lead for Thought Leadership in Higher Education. I'm genuinely thrilled to be spending this time with you today. Before we dive in, I just want to do a quick recap of where we've been. On Day 1, we explored human and AI partnerships. Specifically, we looked at where AI best supports learning and how it can risk displacing thinking altogether through a lens of human-AI teaming. On Day 2, we got into the ethical AI principles for responsible innovation in higher education. That was a very powerful session on authenticity, on integrity, on human agency in an AI-enabled learning environment, and more importantly, how those align with AI use within our enduring academic values that we all hold very dear. If you missed any of those sessions, don't worry, both are available on demand, so please go back and catch up when you can. If you haven't yet signed up for tomorrow's session, it's going to be a live panel discussion on the future of work. I highly encourage you to do that now. We'll put the link in the chat again. I really think this series just keeps getting better day by day. So on to a few quick housekeeping notes. As a reminder, this is a multi-day event. Many of you have come for the first couple of days. Some of you are joining for the first time today, but each session stands on its own. So please do share this with your teaching colleagues. Encourage them to register. They can register and watch on demand as well. For today specifically, we have a great speaker. His name's Jarrad. He's going to be taking us through a hands-on walkthrough of how LLMs actually work. He's going to use the entire session time today. We have about an hour together. So if you do have questions that we don't get to answer live, please put them in the Q&A panel on Zoom. That's the best way to make sure that they're seen and we can answer you through the Zoom chat. You're also welcome to use the general chat function to connect with colleagues. That's a different feature. We have the Q&A, then we have the general chat. When you use the general chat, which everyone can see, please keep it positive, keep comments respectful, and really importantly, no sharing links in the chat. Even if you have well-intentioned links that you want to share with colleagues, these can pose security risks for all of our attendees. So that's a firm ground rule, and really thank you for understanding that. Also, Zoom has closed captioning availability, so you can select your preferred language right within the platform. So be sure to make use of that if it's helpful to you. And here's something to look forward to. As a thank you for attending live, please keep an eye on your inbox over the next few days for your Credly badge of attendance. It's really a terrific way to recognize your professional development. It's also a perfect way to share on your LinkedIn as well. All right, so let's dive into today's session. So when I first started using AI, honestly, it felt like a bit of a black box to me. I would type something in, I'd wait for something to come back, it would come back, and then I would kind of ponder, how did that just happen? But I'd quickly move on and just focus on what the output was. And I hear this from a lot of educators all over the world, that they think about AI in the same way. Most of us are using these tools without really understanding what's happening behind the scenes. And that's totally understandable. But today we're hopefully going to change that a little bit. Today, Jarrad's going to show you how to demystify AI. He's going to help us walk away with a clear, non-technical explanation of how agentic AI and conversational AI work. He's going to break down some real neat examples for us, show us some cool tools. And from that, he's going to give us some practical insights that are going to help you, and by extension, your students, use generative AI more effectively. So our speaker here today is Jarrad Merlo. He's a senior manager in Pearson's Innovation Accelerator. He's also an AI product manager. Jarrad is focusing on language testing innovation. He leads early stage product discovery across different products, development, and design teams. Before he joined us at Pearson, he co-founded E2 Language by serving as the head of product. He was building one of the world's largest English test prep audiences. They had over 3 million YouTube subscribers and hundreds of millions of views. He's a former teacher himself, and his academic passions span conversational AI for speaking assessment, automated scoring, and use of global English. He's exactly the right person to walk us through this today. And Jarrad, the floor is yours.
Really appreciate the introduction, and hello, everybody. First of all, I will say I don't come from the higher ed world. As Vince mentioned, I come from this strange part of the world called language testing. So a lot of the sort of examples that I'll pull and show during this presentation will come from that. But the good thing is linguistics and language sort of underpin everything, so it's going to be relevant to you. Okay, so this is going to be a sort of presentation in 3 parts. Part 1 is going to be on agentic AI. I'm going to demystify that for you. Part 2 is going to be on conversational AI. I'm going to demystify that one for you. We will also dive into how LLMs work at a pretty bit of a superficial level. I'm an AI enthusiast, not an AI scientist, and maybe that's a good thing. And the third and final part, I'll pull it all together by talking about conversational agents, which is where this crazy world is all heading. So let's get started with the first part of the presentation, which is agentic AI, recent, past, and present. Okay, so I'm going to make some assumptions here. I'm sure you guys all know what ChatGPT is. You probably all lost track of the incremental AI updates that are happening every single day. I'm an AI product manager and I can't keep up with what's happening. It's insane. And number 3, you've probably heard of agentic AI. Maybe you've even played with it, and that's a great thing if you have, but maybe some of you don't really know what it is. And it's a very important part of this whole conversation around AI. It's a super important part. It's a very powerful part, actually. I've got some more assumptions here. Like me, you probably have a bit of a status quo bias. You kind of like things the way they are. And like me, you have what's called loss aversion. You like to hold the things that you have and not lose the things that you could have. And like me, you fear de-skilling and unemployment. And I say this because I don't want to come out of the gates here as a sort of, I say I'm an AI enthusiast. I'm deeply interested in AI, but I'm certainly aware of the social impacts and the potential, well, what will be the ethical impacts of AI as well. And I think at Pearson, we're super conscious of that, okay? So I don't want to wave this thing in your face, so to speak, okay? Now, I think some of us may have some AI resistances, and I want to test these today. So when you sort of say to your colleagues or say to yourself that AI hallucinates and we can't trust it, well, I'm going to test that today. Number 2, it'll never have the human touch. When we talk about conversational AI in part 2, I think I'm going to test that one as well, because I believe it probably can now with voice. And number 3, and this is really where agentic AI steps in. AI can't do sort of really complicated multiple step tasks that I as a whatever you do in your job do. And again, I'll test that one as well. So what I can do is sort of place you, or maybe you can place yourself in this quadrant somewhere with respect to the significance of AI from low to high on the y-axis, and your understanding of AI from sort of oblivious to you think it's boring or maybe mind-blowing. So just for fun, pick one of these emojis. Who do you think you are at the moment? In which space do you occupy? Because I'm going to be trying to push you up into a higher understanding of artificial intelligence and an awareness of the significance of it as well. So I'm going to try to get you to become a brain exploding emoji. So just for this section, I'm going to define agentic AI. It won't make much sense. Then I'm going to compare LLMs and agents. So I'm going to sort of look at ChatGPT versus agents in terms of their knowledge, memory, tools, the environments they live in, and their triggers. We're going to look at, in my world, which is a very simple thing, which is how to write a test question. And I'm sure as educators, you've written a bunch of test questions. And we're going to look at, that really is a craft. And we're going to look at how agentic AI can actually automate test question writing. I'm going to skip the discussion because I've got a lot of slides to get through. So here's my definition, and it won't make much sense to you. Okay, so an AI agent is an augmented large language model that performs tasks in digital environments using tools. That's the classic sort of definition without context or without example. And it probably puts you down here in low significance and low understanding of agentic AI. So let's dig into it. You all know what ChatGPT is, right? You've all used this interface. As Vince said, it's this magic where you put in a question or you put in something and it writes back to you. And it's no longer just writing back poetry or, summarizing paragraphs. It's getting to the point now where, well, on the benchmarks, it's at sort of PhD level. So it can come back at you with pretty significant intelligence. So let's compare that sort of ChatGPT interface or the LLM with agents. So, an LLM, that ChatGPT interface, largely is trained on internal knowledge, right? It's got training data, which is where it draws its answers from. The statistical probability of the next token or word that comes from its internal massive amount of training data. An agent, however, can also reach outside of its internal training data to augment its answers. I'm going to dig deeper into these in a second. We're going to talk about memory, short-term versus long-term, LLMs versus agents. Number 3, I'm going to show you how the tools work, because this is key when we think about AI agents. ChatGPT can't really use tools right now. However, agents can. They use things called APIs and integrations to actually go out onto the internet, into specific web apps or spreadsheets, etc., to perform tasks. LLMs live in environments where you're interacting with a chatbot, or as we'll see later, with voice, whereas agents are unbound and increasingly unbound. They now live not sort of in the cloud, but on your computer. And you might have heard of things like OpenClaw, etc. It's getting pretty crazy. And I'll also touch on triggers. So knowledge. I said that large language models sort of have internal training data, and you probably know that what they do is they predict the next, and you can see my little gap fill there. In your mind, you might have thought of word or token, and it's kind of what humans do, actually. There's a funny thing, because if I stop my sentence, you have this sort of anticipatory reaction to me. That's how your human brain works. This kind of works in a similar way using neural networks, but it predicts a token. And an LLM like ChatGPT is effectively, imagine taking the entire internet and turning it into a zip file. And so if you had all of that training data, being able to predict the next word becomes that sort of what it does. And this is really the core of large language models, this next token prediction. And this is how it actually is kind of intelligent, and it's magical. Now, if we compare LLMs and their gap fill next word or next token prediction, agents can do more than that, right? What they can do is they can retrieve from external, outside of their own training data, as I said before, something like a spreadsheet. So this simple example here is an LLM augmented, so it's an agent. It's a ChatGPT, but what it can do is reach outside, say, into a Google spreadsheet of, say, your student's performance data and retrieve that for you. Okay? It can do other things, retrieve knowledge from elsewhere, like it can do grounded web search as well. It can go and scrape websites. Memory is another part where agents sort of differ from LLMs. Now, it's funny because I made these slides about 6 months ago, and things have changed radically just in 6 months. So LLMs do have sort of shorter term memories. They're context dependent on the window that you're using, so the chat that you're in. And they're increasing in size, right? I think, up to a million tokens or whatever it is, I think is Google Gemini, which is huge. So for in that particular window and that discussion you're having, they have memory, and they're improving their ability with memory by using these sort of techniques, by collapsing the chat, etc. Agents have long-term memory because you can plug them into databases, and so their memories will be persistent. Okay, so they will remember things, say, forever. And there's a different way to think about memory here too, which is working memory. So, when you're dealing with ChatGPT or Claude or Gemini, it has a sort of the ability to think through something, to reason through something just for a relatively short period of time. Agents can use their working memory, their reasoning, for now up to multiple hours. I think some experiments show sort of up to a day of thinking about one particular thing or reasoning about a particular thing. Number 3, big difference between sort of ChatGPT, and this really is the core of it, and this is why they're agentic. They have sort of agency, is because they can choose to use particular tools, right? So AI agents, ChatGPT, you can't really plug it into, say, Figma or WhatsApp or Google Drive or your LinkedIn, etc. However, with agentic AI, you can. And so it has sort of either native integrations with these apps, or it has what's called an API request, where you can do something a little bit more manually. Let me give you a really good metaphor. If you're not techie, this is the best way to understand what an API is. And you'll probably hear this increasingly over time. When you go to a restaurant, right, and you look at the menu and you decide you want a hamburger, you don't walk into the kitchen and tell the chef that you want a hamburger. What you do at a restaurant is you look at the menu, you tell the waiter, and the waiter then goes into the kitchen and tells the chef, okay? And what happens is the chef cooks your hamburger, the waiter then delivers the hamburger back to you. What an API is effectively that waiter. It's effectively data transfer. So let's say your agent wants some data. Well, it uses an API which would connect to another system, another website, for example, and that's how the metaphor works. So agents use APIs to connect across the internet to different websites and different applications, etc. And actually, not finally, because I've got one more. Penultimately, I should say, they live in different environments. So LLMs live in these chatbot-based environments. They're contained. Increasingly, they're sort of leaving their environments to help you with your query. But agents live in this sort of strange, unbound or uncontained sort of way whereby they have full access to the internet. And it's sort of similar to the stuff I've been saying. This is kind of terrifying, because the idea of AI safety in the early days was that we needed to air gap AI from the internet, that we would be safe from AI as long as it couldn't access the internet. And of course, those days are well and truly over. AI is not just on the internet, but agents are actually starting to form their own type of internet. A sort of the internet, if you like, is sort of forking into the human version of the internet and an agentic form of the internet. So we're going to see radical things happen over the next few years. And finally, when you want to get an answer from ChatGPT, you go to your computer, you go to your phone, you put in your query, and it triggers it, right? But agents are triggered, that is, they can execute their tasks through a range of multiple different triggers. Maybe it's a Facebook message, maybe it's a GitHub command or whatever. So that, they function very different. They're not human driven in that sense. And again, that's why they're agentic. They have their own sort of agency. So maybe now you've got sort of a little bit more of an understanding of agentic AI and perhaps a little bit more feeling of its significance. But I want to push us right through to the edge here. So as I mentioned, you may have some resistances around AI, and I used to hear this in a few years ago, and I would hear this at conferences. And because I work in AI, I would sort of have to leave those conversations because it's kind of I figure they're kind of like coping mechanisms. You know, oh, AI hallucinates; it'll never be able to do this or do that, etc. Well, as we saw, now agentic AI can, yes, it will use its trained data, which is hallucinatory, but it can augment that with what's called retrieval augmented generation, diving into databases, going to specific websites, whatever. So I won't say it's not hallucinating because the nature of these things is a hallucination, but it's increasingly becoming super accurate. Okay, so I do want you to get rid of that resistance. I don't want you to say that anymore. I think in 2026, that one's dead. Number two, we're going to touch on next in conversational AI about the human touch and voice presence. But also long-term memory helps here because the human touch has to do with people remembering things about you in conversation. And as we saw, it's getting better with memory, more persistent memory. And number three, AI can't do complicated multi-step tasks. Well, let me talk to you about this in the context that I work in, which is language testing. So, you know, the mainstay of a language test, the backbone of a language test is the question itself. You have to write questions. And these are complicated things. They require expert item writers to, draft and write and double check and do all these crazy things here. Research, synthesize, produce, record. I mean, here we've got a listening one, so it has this added complication of an audio file. It's multimodal. So, for a long time, when ChatGPT just came out, people, of course, were like, oh, write me some multiple choice questions. And they were pretty bad. They're really bad. But increasingly with agentic AI, they're getting much, much better. So, when we added the human and say ChatGPT could help the human to choose a topic for the question, choose a subtopic. Maybe ChatGPT was quite good at doing research, but at that point, it was ungrounded research. It was just hallucinatory. ChatGPT was great at number 4, and I can see my numbering's gone skew with here, but synthesizing sources, producing a text, these sorts of things are what ChatGPT was fabulous at. And it was sort of helpful at, say, writing a question prompt and writing the answer options and writing plausible distractors, but not really. And then when it came to actually recording, say, an audio file for this listening multiple choice question, it just couldn't do it. So it's kind of helpful and it would augment the human. Agentic AI, and I'm going to show you a workflow in a second, can do all of these things and do them extremely well. I would say it can't do that to the point of an expert trained human item writer, but it can get a question like 90% of the way there now, with human in the loop, of course. So what we're looking at here is an agentic workflow. And you might hear this term, maybe you've heard this term, or maybe you'll hear this term more and more. And so what we're specifically seeing is an agentic workflow that is producing a test question, right? Let's just call it for argument's sake, let's call it a multiple choice listening question. And so it's doing all of those things that the human used to sort of do by themselves or have ChatGPT or help them to do, but now it can do it because it can do things like, say, the subtopic selector, it can reach out to Wikipedia to find an interesting topic and subtopic for the question. This is not a good example. I shouldn't have used this one, but other workflows, it can produce audio file because, as we saw, it can use tools and API requests. So it can reach across to, say, 11 labs, which you might be familiar with, to generate audio files. It could generate images. It can generate videos. So whatever you need in your test question. And then the test question itself, if you want to write a valid, reliable, accurate test question, you can use one of these latest models like Gemini 3 or Opus 4.5 with web grounding and reasoning skills. It can get a test question really, really close to ready. And the terrifying thing about this is that a human, say by himself, writing a single test question might I'm talking like a super duper high quality one in for a high stakes test might, with audio, would take about 8 hours and cost, say, $400. Augmented with ChatGPT, you could bring that, down a couple of hours and $100. The terrifying thing about agentic AI is the cost of using one of these workflows. We can bring that down from, say, $400 or $300 to 11 cents. And it can write it not in 6 hours, but in 30 seconds. And even more terrifying, the speed is decreasing here. So these slides were just 6 months ago. It was 30 seconds. This is before some of the flash models that came out. So we're reducing time from 30 seconds to under sub 10 seconds to write one of these, including an audio file generation. And the cost is also decreasing. I suspect the cost has been halved now. It's about 5 cents per question. So I touched on sort of ethics and things like that before. I mean, it's kind of a utilitarian argument now with respect to AI, because yes, some people are going to be impacted, say test question writers, but I think we'll see incredible learning products, especially from Pearson, being developed because, well, in my field, language testing, one of the bottlenecks in prepping for these tests has always been a lack of preparation and a lack of mock tests, a lack of personalization in those mock tests. And now we can do that. Like all of a sudden this has been unlocked. Anyway, so I hope some of you are sort of getting a bit of a brain explosion from this and maybe applying it to your own context. But just to touch on this again, the possibilities now are crazy, right? Because test questions, and I'm sure you have to do this in your field, whatever your domain you're in, whatever you're teaching, the items now can become abundant. So if you're delivering exams, which I'm sure you do, limitless practice, more secure tests because your test banks are infinite. Personalization to the level, length, and interest of your students, perhaps. We can now, as I mentioned, we've got these flash models. We can create items instantaneously. So if you're doing something in the classroom, boom, you can produce a great test question in sub 10 seconds and keep everybody engaged. You can do also radical things like tagging those items for, say, diagnostic tests and whatnot. So the impacts on learning are going to be awesome, but there will be other impacts, of course. But here's a practical takeaway. So you probably heard about Claude Code. And I'm going to spend a little bit of time here because this is relatively new. But according to Claude, and according to a hell of a lot of people on the internet, coding has been solved. That is, we have crossed a threshold where software developers no longer need to write code. Okay, this is crazy. This is the printing press or some other historical analogy where we had some people doing a specific thing and a new technology comes along, and then it's not that they become redundant. I really do not think that software development will become redundant, but the writing code will become a thing of the past and maybe an art form rather than something developers do every day. And there's another sort of massive implication of this. It's incredibly easy to do. And so one thing I would encourage you to muck around with is go to Claude. I think it's Claude.ai. It's very similar to ChatGPT, by the way. It's a sort of ChatGPT competitor. And I think you have to pay $30 for the month, but maybe it's worth doing this. Do some software development, because all you need is the English language in order to do that, in order to prompt what is an agentic AI to actually write you websites or particular software that you use. Maybe you do something repetitively in your class that's very time consuming and you're using spreadsheets or whatever. Code up. And I swear you could do this. You just have to be courageous and a bit experimental. And again, you don't need to code. You're just explaining in English language. What you're really doing is specifying the intent, what you want, and it will produce a little piece of software for you and it will work. It's madness. So yeah, I'll give you one example that I did recently. I play pool. I play competitive pool, and my pool hall was using pieces of paper for the pool tournaments, and it was pretty complicated because there's round robin tournaments and double elimination and all this sort of stuff. So I went home. I spent 2.5 hours talking to Claude Code, and I coded our own software for the pool hall, which now is used, and it works, and it's fabulous, and it's made something manual and clunky really interesting and fun. I'm going to skip the questions because I'm going to move into this part of the presentation. I'm going to kind of rocket through this. So we've talked about agentic AI. I want to talk about conversational AI. Okay, the past, present, and very near future. So we're switching gears here. Now, you know what conversational AI is. You've probably spoken to ChatGPT on the phone, and it hasn't been a great experience up until relatively recently, and I'll explain why that is. So let's talk about the past. Actually, let's talk about pre-ChatGPT in the past of voice recognition software, like the ones in your car, or God forbid, Alexa and Siri. And these were terrible. In fact, I think I have some sort of trauma from using these systems, because I remember my brother had voice recognition in his car, and he'd say, "Hey, watch this." And he'd say, "Call Peter." And the car would say, "Calling John." And he'd say, No, call Peter. Calling Sally. You know, I'm sure you've experienced that. One of the reasons is that these systems use these sort of what can I call them? Sort of primitive speech recognition systems, natural language understanding, a multiple cascading system where bits and pieces are joined together. And so there would be this error propagation, right? I won't get into that. I'll talk about that in a second. But also these systems were not built on LLM. So you had to use these very prescriptive slots, call somebody or play something or set alarm for it. It didn't have the flexibility of language, right? Poor dialogue abilities and weak memory. And I'll give you an example here.
Alexa, please play I Shall Be Made Thy Music by Garth Hewitt.
I can't find the song I Shall Be Made by Music by Garth Hewitt.
For goodness sake, there was a...
And you can see here Anne is furious with Alexa for good reason, because Alexa lacked the flexibility that large language models have. It was a prescriptive type of system. So we've moved well beyond that now, and we're actually can move beyond our trauma of these old systems. I'm beginning to, at least, into the present. And the present looks like this. When you chat to ChatGPT or most conversational AI systems, they're built on what's called a cascading model. So they have a sort of 3 components or 3 modules that are linked together. The first one is how it listens to you or how it understands you. And how it listens to you, not how it understands you. And it uses speech to text. So when you speak into this thing, it turns it into text. It transcribes what you say. Then it sends that transcription to a large language model to come up with the response, and it turns that text-based response into speech, okay? So this is how these work, and they're frustrating. When I speak to a conversational AI, it kind of feels like I'm speaking into a bit of a void.
Yeah, I totally get that feeling. It can definitely feel a little like you're just talking into the air sometimes.
Like, why is there such bad latency when I speak to you?
Yeah, I know that little bit of lag can be a bit of a buzzkill sometimes. It's basically just the time it takes to process your speech, turn it into text, think of a response.
So let me get this. All right, so you get the point. And I'm sure you've had that experience. I mean, don't get me wrong. It's like, it's kind of magical that we can speak to our devices, and yet I'm still dissatisfied because it's not quite human-like. So let's discover why, or what some of the limitations are of the current conversational models. And this applies to me again in language testing, because, you know, language tests have a speaking test, and the speaking tests are typically done with a human in conversation. And yet Pearson's PTE does monologic ones, so it doesn't have the conversational element. But we need to get to a point where these resemble humans so perfectly that, you know, we can use them for, say, high stakes language testing in conversation, but we're not there yet. So how does the listening component work? Well, simply, you know this, it's voice to text or speech recognition or ASR or machine dictation transcription. This is common. This has been around since the 1950s. Obviously, it's improved enormously over the last few years, but this is a sort of quite an old technology. It has its challenges, speech to text. Okay, so if there's background noise, let's say you're conversing on a busy street and there's traffic noise, transient noises, as an ambulance goes past, it's going to interrupt your transcription, right? Or competing speech. You're at a party and there's multiple voices. How does the system know which voice is yours and which is not yours? Or you might be in, say, a noisy room with echoes, etc. So these are some of the challenges. Also challenges around who the speaker is and what their accent is. You know, look at a very simple noun like the word car. You might hear from my accent, I'm an Aussie. And if you look at the flag on the far right, I say car. And so with the New Zealanders, I'm not going to mimic the British or Scottish accents, but the rhotic R in the American accent or Canadian accent is car. It's got a deeper, sort of richer R sound. I don't know what happened to the Aussies. We sort of cut that off. But again, my point is that there's enormous accent variability, and this doesn't even take into account people who are using language as an additional language, and they might have Mandarin accented English or Hindi accented English or whatever. But, you know, one of the ways that this has been overcome is through, again, massive amounts of training data. So OpenAI's Whisper, which is a speech to text, probably the best in the world, has been trained on 680,000 hours of multilingual audio data. So it can account for things like accent. That's 74 years of straight audio files have been training that system. So it's getting better. I won't labor this too much, but again, my world in language testing, you know, we have to ask the question now, okay, so if you think about OpenAI's Whisper and how good it is at understanding basically anybody who speaks, no matter what your accent, or even to a degree your proficiency, but let's just focus on intelligibility. It's phenomenal. It's absolutely phenomenal, better than me. And so when we think about human-rated English language tests, where you need to sit in a room with a human, we find that humans are biased in their ability to understand accented English, unless it's their own accented English that they're familiar with. So there's this thing called accent familiarity bias. You know, and this is a problem. It shows that there's great potential in using systems like Whisper. And again, Pearson PTE doesn't use humans, and it uses monologic systems, which is as far as I'm concerned, give me a machine any day of the week over somebody who might rate my accent as poor just because they're not familiar with it. So there are other massive conversational challenges. One is the messiness of real conversation. This little thing here is from conversation analysis, and this is how we speak. We talk over the top of each other. We make I'm probably doing it right now, sentences that are half formed. You'd be really surprised at how non-written like our speech is. It's terrible. And this is a massive challenge for conversation. And all sorts of disfluencies like wow and I stuttering and revisions and prolongations, etc., as well as classic fillers, or. And if we think of fillers, should we remove them or not? Well, they become actually extremely meaningful. So take this cartoon strip that I produced using ChatGPT. I think, hey, Sarah, did you have a good weekend? This is an employee talking to his boss. She says, yep, it was relaxing. He says, do you mind if I take Friday off? So we have to ask the question then, is a filler like meaningful or not meaningful in a transcript? Well, here, linguists know that it's completely meaningful because it precedes a request, especially with somebody who's in a position of higher power. You'll find yourself umming before you ask your boss to take the weekend off because it signals to your boss that you're going to actually use a request. But there's another massive, massive issue here with speech to text, and that is prosody and paralinguistics. That is the way that you say that your sentence or your words. So it turns speech into text, right? So the sentence or question, how are you doing, can have very different meanings. For example, the way, is his name Joey? I can't remember. Joey says, how you doing? In a flirtatious way. Okay, all of that is lost when you strip out the prosody and paralinguistics into text. You can't tell what flirtation is. But here, when somebody says it in a certain way, you certainly can. I'm going to skip this.
When I speak to a conversation,
but you get my point. There are limitations. So let's talk about thinking. How do conversational AIs actually process what you say? How do they understand and how do they come up with their responses? Okay, this is the sort of second step in the cascade. And again, they're doing two things. One, they have to understand, they have to comprehend what you said, and then they need to conjure up a response before they actually utter it out loud. And this is done via, it's done via an LLM. Okay, it's effectively using ChatGPT without the interface here. Okay, I want to spend a few minutes here talking about large language models and how they work. But again, I'm an AI enthusiast, not an AI scientist, so please forgive me if my understandings are limited, and I have to understand it through analogy, and I'll share those analogies with you. So we know what LLMs are, right? OpenAI, Anthropic, Google, Meta, they own things like ChatGPT, Claude, Gemini, Llama, and God forbid, Grok from XAI as well. And these LLMs are competing against each other, and these tech bros are competing against each other to create AGI and potentially artificial superintelligence, some sort of system that will defeat all of them. And it is an arms race. It's a wild arms race to watch, and I can't believe I'm alive while this is happening. It's historic. This is a piece of technology that I think is by far the most profound technology in my lifetime, and maybe my parents and grandparents, I'm not sure. It's radical what this stuff can do. Anyway, how do they work? Here's a simple way. So we know that they do next token prediction. So when it's doing once upon a time, if you type in once upon, the LLM knows statistically that the next word or a, that indefinite article, is the next token that's going to be produced. And following that, once upon the next token prediction will be times. So a single token is drawn from the distribution of possible next tokens. This token is appended to the context and the process is then repeated. In some ways, it's kind of simple, but it's not. It's radical. But let's dive deeper than that. Let's look at how these tokenizers actually work. So I can put a paragraph in here and you can see the colors there. These are the tokens. Okay, so they're not necessarily full words. They might be parts of word is a token. But what's more interesting, that every token is actually behind the scenes a number, a numeral, an integer. Okay, so these token IDs are linked to the specific word. So your words are turned into numbers behind the scenes. You can't see this. And this is even happening when you're speaking to the AI. This is how these language models understand that they're mathematical machines, actually not really linguistic machines. So let's understand what these are. So a token ID is a unique integer that's assigned to each word. It simply acts as a lookup key, like a name tag or an index. I'll give you an analogy in a second for this. And it's connected to a vector, which captures the meaning. Okay, this is where the maths actually gets into semantics. So think about it like this. You've got a marathon race. Imagine this is a paragraph of text. Okay, so you've just put a paragraph into ChatGPT to get it to do something for you. Who knows what? Okay, so now the paragraph, imagine all the runners of the words. Okay, now if we look closely, we can see that each of them has a bib on with a numeral, an integer. Okay, and so that, again, that acts as the lookup key. And so if we focus in on one of these marathon runners, say this person here, we can see that the word Sally was converted to 1339. And this actually, you can imagine that the ChatGPT would know about Sally. This is a stupid example, but it's got a semantic representation of Sally, that she's 32 years old. She's actually a mother of one, and she's She was the winner of the 9, whatever, you get my point. It has this sort of rich semantic representation of her, but it's found her, or this idea of her, or this representation of her through numerals. Okay, so that's the vector. It's a mathematical representation of information. I'll say that again because it's kind of nice to repeat this to yourself. It's a mathematical representation of information. Information could be Sally. So Sally's 8837. I'll tell you a little secret. 8837 is actually cat, but cat wasn't didn't fit my analogy, so I changed it to Sally. Anyway, and of course, these LLMs have mathematical representations of basically everything in existence now, or close to, or maybe I'm delusional, I'm not sure, at least everything from the internet. And so, yeah, I don't know what to say about that. It's just, it's absolutely wild. But it does raise a sort of philosophical question about large language models. And that is, how should we think about this new technology? What are, Vince said at the beginning, like, he puts in text and it comes up with a response. What the hell is this thing? How should we personify it? How do we think about it? Is it a mind? Is it an oracle? Is it an algorithm? Is it sort of some alien thing? And I think as we these become more embedded in society, we're going to have to think about how we think about them, because, well, AI companions, for example, are going to become a real thing, and kids will probably be chatting to them all day long. And, this is, again, crazy ethical terrain here and really philosophical terrain. But I'm going to offer you 2 metaphors that I think are interesting. One is we can think, and this is from Andre Karpathy, who was the founder of, or co-founder of OpenAI, of ChatGPT. And he encourages us, or he thinks about them as people spirits. Okay? It sounds a bit spooky, but think about it. All of the text from the internet, and that is all of the books that have ever been written, etc., are really the thoughts and impressions from people from a bygone era. Or if they're still alive and still writing today, it's still captured something from them. So it's kind of like this model is summoning the spirits of people and maybe the collective spirit of humanity, something like that. But it's not just text, it's also with images. It's been trained on all the paintings and artworks, and I don't know how you feel about that. It raises issues, of course, audio files and video as well. But here's a metaphor that I really like, and that is that what you're dealing with when you're interacting with ChatGPT is a role player. Okay? It's a role player. It's not a person, it's not a mind. It is simply a role player. And this is from a guy called Murray Shanahan, who works at Google's DeepMind, I believe. Is a fabulous paper if you want to read it. Look up Shanahan LLMs as role players, and you read that paper, and it's wonderful. Because he talks about these things, LLMs, as having no intentions, no beliefs, no knowledge, and no fixed character. And it's important to think about them like this, because they're not people. And we should use them, and God forbid they should not use us. And let me explain what this means as a role player. You've probably played 20 questions before. You know what 20 questions is. In fact, before I show you this, you've played 20 questions before. I'm going to think of an object, a household object. You've got 20 questions to try and guess what I'm thinking about by asking yes/no questions, okay? Now, I'm holding that object in mind, and it's a toaster. I'm thinking of a toaster, okay? LLMs cannot do that. They cannot hold anything in mind. So when the bot is thinking of an object, and the bot says, I'm thinking of an object, guess what it is? And you say, is it bigger than a car? At every given point, it's actually then making a decision about what that object is, but never actually keeping the object in mind until you say, I give up. And it will follow back its thread using its sort of reasoning abilities, or the way that the structure of the conversation has taken place, and finally say it's a star, or it's a rhino, or it's a snail, or it's a book, etc. But it never held that object in mind from the beginning, because it can only do next token prediction. And so that's why it's good to think about these things as role players and not having personhood or identities. Anyway, I sort of digress. but I kind of like the philosophical elements of LLMs. So what have we got up to so far? We know that in these conversational models that they listen, that they think, and that they speak. And speaking is done through text to speech, okay? I'm going to sort of rocket through because I realize I've only got 15 minutes and quite a few slides. So why don't these conversational AIs really sound like people? And that is, think about this, the chatbot output, the conversational AI output, its speech tends to resemble written communication more than spoken language. And in linguistics, we know that speech differs from text. The way we speak slightly, or maybe not so slightly, is very different from the way something is written. And you know this yourself when you write in a different way than when you're hanging out with your friends talking. And so these LLMs speak as if they're writing, which is kind of strange. And they also, conversational AI, until very recently, lacked sort of paralinguistics, but have a listen to this. You might recognize the voice, by the way.
How you doing, man? Hey, I've been thinking about the relationship between text-to-speech technology and the ability to convey genuine emotion. It's incredible that we can now make voices that sound so natural and real, not like the old robot voices anymore.
So that's my voice clone, by the way. You can clone your voice very simply, and maybe it's something that will happen in the future. When you have your own AI companion that students will be able to talk to about your subject or whatever. But there's been a shift forward in paralinguistics. It's still not perfect, but it's getting closer. Then there's this. I'm not sure if you're familiar with AI music, and I guess it's a form of speech. I want you to listen to the singer. You're probably familiar with the band REM. I think they were popular in the 1990s. Here is an AI cover of an REM song called Losing My Religion in the genre of soul. I'll just play it for like a few seconds.
Oh, life is bigger. It's bigger.
It's actually an amazing cover. I hate to tell you that you can look that up on YouTube. That was an AI voice. And the thing about AI voices is that they don't need to breathe. So they sing very well. So we've just learned about cascading models, how they listen, how they think, and how they speak. But let's talk about the very near future, because conversational AI has just crossed the uncanny valley. All of that stuff I taught you, sorry, I don't mean to be condescending, told you, is redundant. These systems, these cascading models where they join together bits and pieces are now over. And what we've moved into is what's called speech-to-speech, or a presence model of conversational AI. And this is where speech is not transcribed to text, and text is not turned into speech through a text-to-speech, but what we have is your voice is turned into a vector, which we learned about before, and then the LLM's vector is pumped out the other side as a voice. I can't go too deep, unfortunately, because I'm running out of time, but the critical thing is here that this speech-to-speech models overcome some massive limitations, and they process both the semantics, that is the meaning of the words, and the acoustics, so they can tell how you feel when you speak as well, which is pretty crazy.
About 6 months ago, everything changed with the development of what's called speech-to-speech models. At first, it was sort of more obscure AI companies like Sesame and Ultravox and Hume that had built this technology. But these new models have just been released by Google and OpenAI. If you've heard or played with systems like Sesame, you'll know how incredibly jaw-dropping they are. The experience, the felt experience of speaking to these systems is night and day to, say, the earlier OpenAI model. But what about you? Can you actually hear my voice?
That's a good question. It's kind of different for me. I don't hear in the way you do with ears and, well, brains processing sound. But the signal gets to me as data. Like the waveforms are analyzed and translated into something I can work with. So yeah, I can pick up on the nuances, the tone, even emotion, but it's all through the data. It's not like I'm picturing you speaking, you know?
So what are you getting, like numbers?
Yeah, pretty much. It's a whole bunch of numbers representing the acoustic features of your voice, things like pitch, volume, speed, those kinds of things.
Wow. Okay, so you can play with that conversational AI. You just go to it's either .com or .ai, I'm not sure. And you can chat with Miles, that guy there. It's free. And I guarantee it'll blow your mind. And if you take it home and show your family, it'll blow their mind as well, because it has crossed what's called the uncanny valley. I believe it's crossed the uncanny valley. Like it is indistinguishable from a human voice. You heard the paralinguistics, you heard its breathing, you heard the way that it responded to me with almost no latency. It's absolutely striking. So again, these presence models are built on these vectored vectors. So they have sort of emotional intelligence. They can read and respond to emotional contexts. They have better conversational dynamics with natural timing, pauses, interruptions, and emphasis. It's not perfect. If you speak over the top of Miles, it's not quite like speaking to a human, but it's pretty close. They have contextual awareness. They can adjust tone and style to match the situation. They laugh. They can tell jokes. They have also a consistent personality. Miles most definitely has a personality where he maintains a coherent, reliable, and appropriate presence. But probably the two biggest things to come out of this is the latency has been overcome. So remember when I showed you that video of me talking to ChatGPT and there was that horrible sort of latency? Well, if you look down at the white circle that is flashing now, you can see that it's going through that cascading model, the speech recognition, the LLM, the text-to-speech. And yes, it only takes about 0.8 of a second, but that is enough that it feels unnatural and it's incredibly frustrating. If you see the red circle up the top, that is the latest speech-to-speech model processing your speech and responding in, I think it's 0.3 of a second, 300 milliseconds. And that is where we move into human-like, the psycholinguistics of comprehension and response, etc. So that's one thing. The second thing is, of course, the emotionality. And the big reason why it can deal with emotionality is because it's not transcribing your words. When you speak to it, your words are not being transcribed to text. They're not losing all of that beautiful cadence and richness and the paralinguistics, etc. So it's actually getting all of that in the acoustic tokens, which are again imprinted as numbers here or vectors. So I think I'm doing all right for time, actually. I'm going to finish very soon, but let me just wrap this up by bringing together what we've learned about agentic AI, which we talked about at the start, and conversational AI, because, of course, these things merge. And this is what is known as conversational agents. And this is going to be how we interact with our devices in the very near future. You can think about Siri, for example, as an analog, but we're talking about something way more powerful than Siri, because it's going to have all of the benefits of the agentic stuff, where it can go on, it can go and retrieve data, it can augment its responses, it can look through databases, it can write emails, etc. Except the interface that you're using will not be text-based, you will not be typing to it, but you'll be speaking to it in real time. So this really is the sort of next step of what we're going to see. It already exists, but we're going to see sort of the application of conversational agents to a hell of a lot of products moving forward, especially in the education space, which is cool because having been a teacher, I know that there's so much work involved in, lesson prep and marking, etc., and dealing with student inquiries. So I think this is a good step. This is my final slide. It sort of shows, it's a complicated looking slide. This is a screenshot of 11 Labs, which has a really easy to use conversational agent.
If you haven't played with 11 Labs, that's another one. So I've given you, if I've given you three, I gave you, I gave you Claude Code to play with, to experiment with. Sesame for the conversational AI experience. And another one, if you haven't played with this one, it's called 11 Labs. And one thing I will mention is these things feel and seem very intimidating. As soon as you sign up, you realize that most of them, you are interacting with it through natural language and typing or voice. And so they're not that intimidating. But anyway, what this thing can do is, well, it can speak 36 different languages. We're using this to prototype some really interesting language learning and test prep products in my division. It can go and say you do some practice questions. It knows what questions you've answered. It knows all sorts of stuff, and it can respond in real time as you're having a conversation with it. So this is probably the future of this so-called AI tutor, which we haven't really seen a good one yet, but I think Pearson is onto that. Anyway, I'm going to wrap it up there. I'll stop my screen sharing, and thank you very much for listening. I hope that was interesting.
That was great, Jarrad. Thank you. I really appreciate that. I think this is really what the educator community needed. I personally appreciated kind of how you took us through the framework of agentic AI, gave us more of a deep understanding about how conversational AI works, really kind of shone the light on how tokens work. I didn't realize, they were so mathematical, so, data oriented. So I'm also still kind of stewing on your comment that AI is a great singer because it doesn't need to breathe. For me, at least, that was equal parts illuminating on why AI is so powerful and why it's advancing so much, but also slightly petrifying as well. But no, I really appreciate that. That was an honest look of how AI works under the hood. I think for me, I was thinking like, this is technically non-technical, and I think our audience will kind of understand what I mean by that. Like you really made it accessible while showing us kind of technically how these systems work. So I think a lot of us are going to walk away today seeing these tools in a different light, with a better, deeper understanding of them. So thank you for your time today and your expertise. To everyone who joined us today, I want to thank you here for being live. Please keep an eye on your inbox over the next few days. You'll see your Credly badge of attendance there. Wear it proudly, share it on your LinkedIn. You've really earned it. And please do not miss our final, last but not least, day 4 tomorrow, our final session of Shape the Future. We've had a terrific panel organized. They're going to bring together higher education leaders, enterprise executives, also a few students as well, for grounded real world conversations on the future of work. So I think it's something that's very practical, very applied, and something I'm thinking a lot about. So it's going to be a brilliant way to close out the series, and we'll see you there tomorrow. Okay, everyone have a great rest of your day. Take care.